Our next topic is linear measure. Measurement actually is dealt with very early on in the Common Core State Standards. You can see by this first grade standard that students are expected to order objects by length and compare the lengths of two objects indirectly using a third object. So what that indirect comparison means by a third object is something like this. Suppose you have a pencil and a paper clip, and you want to know how many paper clips long is the pencil. So you might be expected to line up the paper clips and count how many of them are the same length as the pencil. So the paper clip is considered a non-standard unit of measurement. In second grade, students are asked to measure using some customary units of measurement like inches or feet or centimeters. And they're also asked to look at the same object and measure that object using different units of measurement and explain why these units of measurement result in different values for the length of the object. So for example, the Crayola might be called about 2 inches long, or if it's measured in centimeters, it would be said to be about 5 centimeters long. So a student would be expected to explain that the crayon is a greater number of centimeters long because a centimeter is a smaller unit of measurement than an inch. Now we use English units of measurement in the United States, and what makes them so difficult for students to understand, and for that matter for adults to understand, is that English units use fractions to divide up our basic units of measurement. So for example, if we're measuring an inch, we could measure a half an inch or a fourth of an inch or 3/8 of an inch. So fractions are what make English units so difficult. If we're measuring with this ruler and we're asked how long the paper clip is, we would need to be able to say that the paper clip is 2 3/4 units long. By fourth grade, students are expected to be able to measure in both the English unit of measurement and metric units of measurement. English units of measurement are the ones that we all grew up with. That's feet and inches and yards and miles. There are lots of other units of measurement in the English system, but we're concentrating right now on just units of length. You may be wondering, who uses English units of measurement? Oddly enough, the English do not use them anymore. In fact, if you look at this map, the countries in red are the countries in the world that use the English units of measurement. That would be the United States, Liberia, and Myanmar. Although Liberia and Myanmar are both said to be moving away from the English unit of measurement, which will mean that eventually the United States will be the only country using these units of measurement as a standard unit. So how do we convert from one unit of measurement in the English system to another? Well, it's a kind of cumbersome relationship between the units. For example, there are 12 inches in 1 foot, there's 3 feet in 1 yard, and there's 5,280 feet in 1 mile. So if we want to convert from one unit to another unit, we have to know these conversions to do that conversion from one unit to another. So let's keep those conversions handy while we think about this. A twin bed is 39 inches wide. How many feet wide is it? Let's look at several different approaches to this problem. One would be to say, well, if I know there's 12 inches in 1 foot, I can just start to add inches together until I finally have 39 inches. So if there's 12 inches in 1 foot, then 12 more inches would have to be 2 feet, and 12 more inches than that would have to be 3 feet. Now if I add an additional 12 inches, then I have 48 inches, which is wider than my bed. So I need to think about how many more inches I need beyond the 36. And that would be 3 more inches to get me up to my 39-inch wide bed. So how much of a foot is 3 inches? Well, 3 inches is 3/12 of a foot because there's 12 inches in 1 foot. So if I take those last 2 lines in the table and add them together, I'll get 39 inches is 3 3/12 or 3 1/4 feet. Here's another way we could do the same problem. We could set up a proportion using the fact that there's 12 inches in 1 foot. So if there's 12 inches in 1 foot, we want to know how many feet are in 39 inches. So we'll set up a proportion making sure that we match up the units that we're comparing. We're comparing inches to feet, so we want to make sure we keep that order the same in both fractions. If we cross multiply, we can solve for x and get that x is 39/12 or 3 1/4 feet. And yet a third way to look at this problem would be to look at the relationship between inches and feet as a conversion factor that we can use as a ratio that we can multiply values times. Now the reason why this works is that 1 foot and 12 inches are equal to each other, which means we're really multiplying by a fraction that's equal to 1. So we haven't really changed the value of the 39 inches by multiplying by this fraction. In this method, we can cancel out our units, and the units we're left with are just the feet. So we have 39/12 feet, which once again is 3 1/4 feet. The metric system is a lot easier to work with when we're converting from one unit of measurement to another, but because it's unfamiliar to us, it may not seem as handy to you. It's based on base 10, and there are prefixes for each of the units that are universal, whether we're measuring in linear measure like we are right now, or we're measuring weight, or we're measuring volume. The base unit for length is the meter. And when we look at those prefixes, we can tell by the prefixes if we have a unit of measurement that's larger than another unit or smaller than another unit. Now you'll notice in the middle of this where it says unit, that represents whatever base unit we're working with. In this case, we're talking about linear measure, so our base unit's going to be the meter. So if we put these prefixes together with the unit, we could have a decimeter or we could have a millimeter. Those are ways to express units of measurement in the metric system. Now, if we look at the relationship from one unit to another, we can see how one unit of measurement can be put together as smaller units to form a larger unit. For example, if you compare the centimeter to the meter, the centimeter is 2 places to the right of the meter. That would be 2 powers of 10 to the right on this scale, which is 2 powers of 10 smaller than a meter. So a centimeter is 1/100th of a meter. If we compare millimeters and meters, the milli prefix is 3 places to the right of our unit measurement, so that means it's 3 powers of 10 smaller than a meter. So a millimeter is 1/1000th of a meter. On the other hand, the units of measurement to the left of meter are larger. So if we're going to compare kilometers and meters, we can say that the kilo prefix is 3 places to the left of meter, which means it's 3 powers of 10 larger than a meter. So a kilometer is 1,000 meters. Now, keeping this conversion in mind will help you convert from one unit of measurement to another. So let's say we want to convert 457 millimeters to centimeters. If we compare where millimeters and centimeters are in relation to each other, we can see that millimeters are the smaller unit of measurement and centimeters are the larger unit of measurement. And in fact, we can see that there is one place, 1 power of 10, between them. So we're moving to a larger unit of measurement to go from millimeters to centimeters, which means we have to have a smaller numeric value representing that. So we have one place that we're moving from millimeters to centimeters, which means we need to move our decimal point one place to make a smaller number for our larger unit of measurement. So 457 millimeters is 45.7 centimeters. How about if we have 1.5 kilometers and we want to know how many meters that is? Well, a kilometer is a larger unit of measurement than a meter. In fact, it is 1,000 times larger because it's 3 places to the left of our unit measurement, which is the meter. So a kilometer is larger, a meter is smaller. We're moving to a smaller unit of measurement, which means we need more of those units to equal the 1.5 kilometer. In fact, we need 1,000 times more for our 3 places that we are moving our decimal. So 1.5 kilometers is 1,500 meters. Now, when we're measuring linear measurement, we can also do things like measure perimeter, which is the distance around a figure. If we have a figure like a triangle and we want to measure its perimeter, all we have to do is add together the lengths of the 3 sides of the triangle. So this triangle would have a perimeter of 12 meters. If we have something like this quadrilateral, we know that it has 4 sides, so to find perimeter, we simply add together the measures of the 4 sides to get a perimeter of 18 feet. Now, if we have something like a circle and we want to measure the distance around the circle, it's a little bit trickier than measuring the distance around a polygon. Now, one thing to keep in mind is that if you hear the word circumference, it really means the same thing as perimeter. It just means that we're measuring the distance around a circle when we're measuring circumference. So let's suppose that we have a circle and we know what its radius is. If we want to know the circumference can be found by taking 2 times pi times the radius of the circle. And if we know the diameter of the circle, we can find circumference by taking pi times the diameter. Now, these two formulas really do the same thing. The one on the left, you'll notice, has 2 times a radius in it, and 2 times radius is diameter. So these are really 2 formulas for exactly the same thing. The one on the left we want to use if we know the radius of the circle. The one on the right we use if we know the diameter. And you'll notice that both of the formulas have pi in them. If we want a decimal approximation for circumference, we can substitute 3.14 for pi, which is an approximation to 2 decimal places for the irrational number pi. So let's suppose we have a circle that has a 3-inch radius and we want to find its circumference. Well, first we have to figure out which one of these 2 formulas we're going to use. Since we know radius, we'll use the formula on the left. Since the radius is 3 inches, we can find the circumference by taking 2 times pi times 3, which is 6 pi inches because we're measuring our radius in inches. 6 pi inches is the exact value for circumference. If we want a decimal approximation, we'll simply multiply 6 times 3.14 to get approximately 18.84 inches. What if we know the diameter of a circle and we want to know its circumference? Well, in this case, we'll have to use the second formula, that circumference is pi times diameter. And if the diameter of the circle is 10 centimeters, then the circumference is 10 times pi centimeters, which once again we could approximate as a decimal by substituting 3.14 for pi and getting 31.4 centimeters. Now, circumference is the distance completely around a circle. An arc is just a portion of that circumference. So if we think about a portion of the circumference of a circle, we can define that portion by talking about an angle that we're measuring inside the circle. For example, if we're measuring this 90-degree angle, we could be looking at that yellow part of the circumference as representing the arc of the circle that is subtended by the 90-degree angle. Now suppose this circle has a radius of 16 feet, and we want to find how long this 90-degree arc is. If we keep in mind that the measure of this arc really has to do with a fraction of the circumference, we can find that arc length fairly easily. We know how to find circumference of the circle. That's 2 times pi times the radius of the circle, so 2 times pi times 16. And the fraction of the circle we can find by thinking about that 90-degree angle that we are using to form the arc. That's a 90-degree angle out of the 360-degree angle, or degrees, that it would take to rotate around the entire circle's circumference. So if we take 2 times pi times 16 times, well, 90 over 360 is 1/4, isn't it? And that makes sense. 90 degrees is 1/4 of the circle. We get 8 pi feet. And once again, we can approximate that using the decimal approximation for pi is 3.14, and we can get approximately 25.12 feet. Let's try another one. What if we know a radius of the circle is 16 feet and we want to find the length of a 60-degree arc? So a 60-degree arc would look something like this, and we want to find the length of that arc. Well, certainly we could find the entire circumference of the circle by taking 2 times pi times its radius, but we don't want the entire circumference. We want 60 degrees out of the 360 degrees it would take to rotate around that entire circumference, which means we want 32 pi times 1/6, or 16/3 pi feet, which we could approximate as a decimal by substituting 3.14 for pi and get an approximate 16.75 feet for the length of that arc. So that's a look at some linear measure. We'll be using linear measure in other ways in other geometry problems.